Hello everyone, welcome to this class. Today we are continuing with our solution to quadratic equation using the graphical method, and this is the first, I think this is the only exercise that we have here. So we are trying to now solve one on our own to make sure that we understood what we did in the example, because sometimes when you work with what has been pre-solved, you think you know it until you practice it. That's how you know if you actually know it. That's why they say practice makes perfect. So now we have this copy and complete the table 3.3. This table 3.3. We are given this copy and complete table 3.34. Why this in the range that? Remember what I said in the last class? So long as you are seeing this equal to sign or equal to sign means here and here are included. Now we look for the pattern that they are using. This minus 2, and for already they have already given us the values of x, because if they don't give you, we will not know whether we are using integer or using fraction. So but they've given us, so we work with what they've given us. So I will just solve for this table and we'll come back to question number B. This is the first question. So we've been told to complete these places that we don't have value. So what is y? This is the equation for y. Y is 5 plus 2x minus x squared. So let's start filling in the question. So at this point where x is minus 2, y is 5 plus 2 minus 2 minus 2 squared, which should give us 5 minus 4, because of this minus sign here, minus 4. 2 squared is 4, which should give us 5 minus 4 is 1. 1 minus 4 is minus 3. So here will be minus 3. The next one we are going to fill in is this one. Let me put it at x equal to minus 2 here. Next one we're going to fill in is the second one at point where x is 1. So y plus 2, y is equal to 5 plus 2x minus s squared. So at x equal to 1, it will be equal to, y will be equal to 5 plus 2 times 1 minus 1 squared. So y is equal to 5 plus 2 minus 1. 5 plus 2, 7. 7 minus 1, 6. So y is equal to 6. So we'll put 6 here. The next one is at the point of 1.5 at x equal to 1.5. Y is equal to 5 plus 2 times 1.5 minus 1.5 all squared. So y is equal to 5. So 2 times 1.5 is 1.5 times 2, I think is 3, minus 1.5 squared is 2.25. So y is equal to this plus this 8. 8 minus 2.25. Let's solve it here. 8, 2.25. You take 1, 5. Take 1, put here, will be 9, here, 10. Here will now be 7. 7, 5. So you have 5.75. That's y at this point. So you now put it 5.75. The next one is when y is 2. So we just keep doing this. If I reach the point where this book stops, I think I'll just fill in the rest. You can complete the rest by yourself. So don't make this video too long. You have 5 plus 2x minus s squared at x equal to 2. So it was 5 plus 2 times 2 minus 2 squared, which is equal to 5 plus 4 minus 4. 5 plus 4 is 9. 9 minus 4 is still 5, so y is equal to 5. Let's put 5 here. So I will just fill in these 2. So I now have to fill in this remaining 2. Here, after solving, I got 2, and after solving, I got 0.25. This is 0.25. I know 0.25. In case you did not see this one properly. So that's for the first question that we are asked. First question says copy and complete the table for this. We've solved for this. Let's go for the second question. Second question says, taking 2 cm as 1 unit on both axes, draw the graph of this for the given range. So the same thing we did in the last class. I think they're telling us to take 2 cm for one axis and draw this graph. So we'll do that. So this is our graph sheet. Let's use it to start. At point, okay, they say we should use 2 cm for 1 unit. So this is my 2 cm, and this is for 1 unit. So if I go left, I'll have for x. Oh, sorry. This is my, let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is my graph sheet. Let me use it as my origin for the, or I can use here. Should I use here or here? I think anyone can work. Let me use here. So this is my 2 cm. I use it to represent 1 unit. So if I go left, x reach 4 here from what we got. So I hope I can have for 1, 2, 3, 4. So I can have up to 4. So if I go left, I'll have minus 1, minus 2, minus 3, minus 4. 1, 2, 3, and 4. So this is my axis, my origin. So when x is minus 1, y is minus, okay, I've not drawn for y. Y is 1, 2, 3, 4, 5. It's using up to 6 here. So minus 1, minus 2, minus 3, minus 4, minus 5. I think that's where I stop. So at point where x is minus 2, y is minus 3. So this is when at point where x is minus 2, y is minus 3. So I take my first point. When x is minus 1, y is 3. This is x minus 1, y is 3. Where x is 0, y is 5. This is x0, y is 5 here. x1, y is 6. X is 1, y is 6. At point where x is 1.5, y is 5.75. So this is 1.5 here. So y is 5.75. This is 5. Because how do I get this 1.5? This is divided into 10. So this is 1. I'll count 1, 2, 3, 4, 5. So 5.75 is divided into 10. I'll count 1, 2, 3, 4, 5, 6, 7. This is 7 here. Then the middle of 7 and 8. Okay, this is 7 here. The middle of 7 and 8 is 7. The 7. So I'll take this thing straight to the 1.5. This is 1. 1, 2, 3, 4, 5. So that is it. So at point where x is 2, at point where x is 2, y is 5. This is being x being 2, and this is y being 5. So at point where x is 2.5, y is 3.75. This is 2.5, this is 2, this is 2 up. So this is 3. Come here. This is 2. This is 2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Trace this one up. I know it's a little bit rough, and this is 3. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. The middle of 7 and 8. Bring it at point where x is 3. The reason why is as if I'm jumping and pointing here is because I'm mistakenly using this one, forgetting that I wrote it here, so sorry for that. At point where x is 3, y is 2. So this is s being 3 here, and this is y being 2. At point where x is 3.5, y is minus 0.25. So this is 3.5. 1, 2, 3. 1, 2, 3, 4, 5. This is 3.5. And y is minus 0.5. Somewhere here. It's not even up to, this is 0. Then if we are to divide this by, let me explain a bit. You know, you should have 0.1, 0.2, 0.3 till you reach 10. So it's not even up to 0.1. So it should be something here, some very close to this 0.2. So this is a point. This is 3.5. So somewhere here. So at point where x is 4, y is minus 3. So this is s being 4, and this is y being minus 3. So this is like kind of, this is here is not part of what we calculated, so that's why I have to cancel it out. So now that I've picked all my coordinates, the next thing I'll do is to find a line that will connect all of them. So the best way to do it is to find something that is bendable and use it to draw the line to connect it. Let me say something like this that is bendable. Instead of going to, or maybe a broom, you curve it, but let's just do it by ourselves. So just look for anything that you can curve in this way, and then use it to, I might not get it the line properly, use it to draw the line. Because I'm doing it alone, maybe so if someone is holding it for me, I would have gotten it better. Okay. So use it to capture the line. So it will be a bit rough, but you can't just be picking just two lines. You have to pick as like actually where the curve is. Okay, this is what I was able to make up. I'm doing it alone, so it's rough. But if you want to make sure you pick the thing and pass through the curve, because let me say you're just picking only here to here, you end up making a mistake of maybe drawing a straight line. So make sure that you have something that can pass through the curve and pick as much point as possible. So this is like what I was able to get. Let me just do is rough, but the thing is that we can only deviate from our answer a bit since I'm doing it all alone. So see where I picked all the points, all the important points. So go straight. So let's assume this is our curve. So this answers the second question. They say taking 2 cm for 1 unit on both sides. Draw the graph of, this is the graph we are drawing. Let me put it here. Y equal to 5 plus 2x minus x squared. So I think we've answered the second question. Let's go to the third question. Third question said, on the same axis, draw the graph of y equal to 2 using your graph. So what they're trying to say is, on this our graph, not in another graph, on the same axis that we use for this our graph, let's draw the graph of what? y equals to 2. Remember what I told you earlier, that equation of a line, if you have, like they say you should draw this graph y equal to 2, y equal to 2, it simply means that the line will be parallel to what? X-axis, and meet y at point y equal to 2. So this is where y is 2. So it just means this straight line here. So just draw a straight line that will pass through this line in this way. So I'll call this straight line. This line is this, but this straight line I'll call it this. So that's it. That is question C. This is just the solution to question C. So the next thing they ask is, using your graph, solve the equation of this at point 0. Second one, find the value of x for which y is equal to 2. So the equation, anytime you are being told to find the equation of a quadratic equation using graphical method, just know that what they are asking you is, at the point where x is 0, this is where x is 0, this is our origin, what are the values of y? So if I'm to use my graph, I will say that y is 1, 2, 3, 4, 5, 6. So y will now be minus 1.6, and again 1, 2, 3, 4, 5, 6, 7. Y is minus 1 point. That's another 1.6 there. Sorry, this is 3. Sorry, this is 3.6, and it's plus, not minus, because we are the positive side of x. Another thing again, they ask us to find the values of x at point where y is what? 2. So you just look for this value of x and that value of x. At this point you have, this is 1, 1, 2. This is actually x, not y. I don't know why I keep mixing some of all these things, because you're looking for solution of x at point where y is 0. So the second one, let me put y equals to 0. That's the solution of this quadratic equation here. But the second one, they told us to find x at y equal to 2. So x at this point I've gotten minus, let me put x minus 1.2. At the other point I've gotten, this is 3. X equals to plus 3.2. So this is the last solution. Now the next thing we are going to do is, just for the sake of this class, is to confirm if this solution to this our equation is correct. Mind you, we will not get it correct because of the rough work we did, but at least we will be close to show that we know what we are doing. Same thing with this one. So how do we know if we are getting this thing correct? All we need to do is to write this equation here and set y to 0. That's how we'll know if this one is correct. For this second one, we'll still write this same equation and set y to 2. So let's solve that in our next class. Sorry, not next class, next example. So we now have y is equal to 5 plus 2x minus x squared. So at point where y is 0, we have 0 equal to 5 plus 2x minus x squared. So let me put this, let me rearrange this. I'll have minus x squared plus 2x plus 5 is equal to 0. To remove this negative sign, multiply all of them by minus. I have x squared minus 2x plus 5. Okay, this is minus 5. X squared minus 2x minus multiply minus 5 is equal to 0. So let me use the formula method. I'll have minus b plus or minus root b squared minus 4ac all over 2a. A in this case is 1, B is minus 2, and C is minus 5. So minus B, I'll have minus 2 plus or minus square root of minus 2 all squared minus 4 times 1 times minus 5 all over 2 times 1. I've plugged in these values inside these equations. So I have here minus is plus, so 2 plus or minus 4. 4 times 1 is 4 times minus 5 minus plus minus 4 times 1 is minus 4 minus 4 times minus 5, that's plus 20 all over 2. This thing is 2 plus or minus root 24 all over 2. So your x will now be equal to this divide this, you have 1 plus or minus root 24 over 2. So x is now 1 plus root 24 over 2. X is also 1. X is also 1 minus root 24 over 2. So if you punch your calculator and solve this one, you get 3.45. In the same way, if you punch your calculator and solve this one, you get minus 1.45. So from our solution, we got 1.6, minus 1.6, and 3.6. You see that we are very, very close. We are very, 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 very close. Let me put it beside both of them so you see them. See that this is what we got from the graph. Minus 1.6, minus 1.45, 3.6, 3.45. If we took more time to draw this graph properly and put our curve, we'll be more closer. So for the second one, where we solve for the values of x at this point and at this point, where y is equal to 2, and we got these two things. Let's also solve the equation and know how close we are, whether we got it right. So in that second one, we just do y, this is for the second one, equal to 5 plus 2x minus x squared. So I will now say something like 2 equal to, because at that point y is 2, 5 plus 2x minus x squared. So let me say I will have this one come over, I will have something like 0 equal to 5, okay, let me say 5 plus 2x minus x squared minus 2. When these two minus subtract each other, I have something like 0 equal to 3 plus 2x minus x squared. I can put it in this way, x minus x squared plus 2x plus 3 equal to 0. To make this positive and multiply all of them by minus, I'll have x squared minus 2x minus 3 equal to what? 0. I think factorization can go here. What are the two numbers that when you add them, you get minus 2, but when you multiply them, you get minus 1. I think the two numbers are minus 3 and plus 1. So minus 2 and plus 1 gives you minus 2y. Minus 3 and plus 1 gives you minus 2y. Minus 3 times 1 gives you minus 3. So we have something like x squared minus 3x plus x minus 3 equal to 0. Are we together? So what are the common factor here? X into x divided by x is x. 3s minus 3s divided by x minus 3. What is common here? 1, x divided by 1, x minus 3 divided by 1 minus 3 equal to 0. So take the like sense, x minus 3 and x plus 1 all is equal to 0. So x is equal to x minus 3 is equal to 0. So x equal to 3. If you are solving for this first solution, then if you are solving for this side, x is plus 1 is equal to 0. So x equals to minus 1. So these are the two solutions you got, 3 and minus 1. And from our graph, this is what we got. We got minus 1.2 and plus 3.2. So we are close. We didn't if you say let's do approximate, you know this is not up to 5. You can say this is minus 1 and 3, but you can see that we are close just because the graph is rough. You understand? And you know, this class we are solving it on the spot, not like it's a pre-recorded or anything. So these are the solutions, and you can see that so what I'm doing, this calculation I did here is totally out of the class for today. I only did it for us to confirm how close we are with our graph to what we are being told to do. So this is what all about graphical solution for quadratic equation. I'm sure this can only come up in exam where you maybe theoretical exam. Nobody will come and tell you to solve quadratic equation and you just go and start using the graph. So summarizing the questions we did today, we are given a table and an equation. We completed the table using the equation. Then that was the first one. Second one, we took the scale and draw a graph, which is this is our graph, a rough one at that. Then we are being told to draw an axis of y equal to 2, which I explain how to draw this kind of line. Then secondly, we now solve for the equations of the root of this equation using the graph that we draw, and also the value of x at point where y is 2. So this sums it up for graphical method of solving quadratic equation. Please, if you have any question, do well to drop it in the comment section. Thank you. See you in the next class.